Hey folks, this is the first video in section 7.6 that deals with how to solve trigonometric equations. We're going to go through several different methods that will work for solving trig equations. So method number one is just simply to treat it like it's a linear equation. In other words, get the trig equation, the trig function alone, and then we can work on getting the theta alone. Understand that when it says to solve, we want to find theta. That's ultimately what we're trying to do. So first step, get the trig function alone, and then the second step, get theta alone. All right, so when you take a look at this particular equation, let's get the trig function alone first. So we're going to add root 3, and then we're going to divide by 3. I did that all at the same time. And then we're looking for places on the unit circle where, first of all, tangent is positive, so we know that that's going to be either in first or third quadrant. By the way, notice that our restriction is the entire unit circle in degrees. This is not like the previous section where we were dealing with inverse trig, where I actually had tangent inverse. I may use tangent inverse here, but I'm not using those same restrictions because tangent inverse is not in my original question. So I know that my theta is going to occur in either quadrant 1 or in quadrant 3. And so where you're asking yourself, where is tangent equal to root 3 over 3? And so that's going to occur in one of two places. It's going to either occur at the 30-degree mark or at the 210-degree mark. If that is confusing to you, we've done that so many times, I'm guessing that that is not a problem. But if that's confusing for you, remember that tangent is sine over cosine. So in my brain, I was just considering, okay, do I want my sine to be a 1/2 over a cosine of root 3 over 2, or do I want the vice versa of that? And so that was all I was really kind of figuring through in my mind there. All right, so let's go ahead to the second example, the zero factor property, or sometimes this is called zero product property. Now, in order to use the zero product property, one of your biggest clues is that you have to have 0 on one side. And so the first thing I'm going to do is I'm going to take this sign over to the other side. Now, for the record, some people would like to divide on both sides by sine of theta and cancel a pair of sine of thetas. If you try to do that, you will lose solutions. So that is not an option. You never want to divide by your variable and cancel. You will lose solutions if you do that. All right, so let's go ahead and move that sign over to the left side. Sorry about that. I erased a little bit. All right, so, and then I can factor out the GCF. So my GCF is a sine, and so that's going to leave me on the inside with a tangent theta minus 1. So once I have something like this, then I can just say, hey, either my sine of theta is going to equal 0 or my tan theta minus 1 is equal to 0. So I'll set up two little miniature equations, sine theta equals 0 or tan theta minus 1 is equal to 0. And then I'll solve each of those little miniature equation. So on the left side here, where does sine of theta equals 0? Well, I know that that's going to occur at these two locations. Once again, take a look at your restriction. We're looking at the entire unit circle in degrees. So that's going to be either at 0 degrees or 180 degrees. For my other miniature equation, I'm going to add 1 to both sides. And so tangent, again, I'm sorry, I erased part of that. Apologize. Tangent theta is equal to 1. Where does tangent equal 1? Well, I know that's going to occur in the first and the third quadrant because those are my two positive quadrants for tangent. And that's going to occur smack dab in the middle, so either at 45 degrees or at 225 degrees. So I have 4 different solutions for theta. It could either be 0 degrees, 180 degrees, 45 degrees, or 225 degrees. The reflection question, we already discussed that. Why is it improper to divide both sides? Because you will lose solutions. All right, now we also have some quadratic methods. You would have done these in the 2 previous classes before you hit college trigonometry. you just wouldn't have done them with trig. You would have done them with just regular old numbers and variables. So let me show you what I mean by that. Example number 3, again, we're using that zero product property or zero factor property, and it says that we're to solve this guy right here. If you can think of this as 3 times a squared minus a minus 2 equals 0, this right here is what we would have run into in previous courses. We might have been asked to factor those. And so I'm not going to teach you how to factor in this class. That is something that you got to know when you enter the class. So if I were to factor, that would be a quantity 3a plus 2 times the quantity a minus 1 is equal to 0. Well, I'm not really dealing with a's, I'm dealing with signs. So let's do the exact same thing, only with sine of x. And so this will be the quantity 3 times the sine of x plus 2 times the quantity sine of x minus 1 is equal to 0. And now that I have two factors multiplied together to equal 0, I can use my zero product property or my zero factor property and set up two mini equations. So I'll have 3 times the sine of x plus 2 equals 0, or sine of x minus 1 is equal to 0. So let's go ahead and solve the first mini equation. We'll subtract 2 and divide by 3. Now, this is not something that's on our unit circle. It's not a memorized value on our unit circle, so we're going to need to use our calculator for this particular one. I would ask myself, where is sine negative? I know that that's going to occur in quadrants 3 and 4. And so remember that inverses find angles. In order to find my x, I'm going to need to use inverses. And so finding my x, I will set that up as sine inverse of negative 2/3. I'll plug this into my calculator. And when I plug it into my calculator, I'll get x is equal to negative 0.7297. Now, let's go back up to the instructions really quickly and check our restrictions on this. Remember that sine inverse restrictions are only on the right side of the circle. Also remember that whatever's in this quadrant is going to be a negative name or a negative version of the first quadrant. So this guy right here is a negative, it puts us in the fourth quadrant, but it's a negative first quadrant value. All right, so this unfortunately does not match my restriction because all of my values, and since I'm using decimals here, all of my values essentially need to be between 0 and 6.28. So because 2 pi is the same value as 6.28, and my answer right now is not, that is not the case. All right, so how then do I get my two solutions, in one in third quadrant, one in fourth quadrant, starting with what I have right here? Well, the first thing that I would do, I think, is to just simply take this value and add a whole circle to it. Add 2 pi to it. So just use your calculator. Go ahead and type that in. Take your negative 0.7 number, add 2 pi to that. And when you do that, you should get 5.5535. That is a fourth quadrant value. And so that is going to be your fourth quadrant solution. How do I get my third quadrant solution? All right, so let me zoom in here a little bit. So think of it like this. I know that from here to this solution is a distance of this 0.7297 number. Well, my sine value for the third quadrant is going to be the exact same distance from the x-axis. So what I really just need to do is take this value, this distance, not the negative number, but just the distance alone, and take pi and add that 0.7 number to it. So if I take the positive value of this, add pi, I will get my fourth and final solution, which is going to be this 3.8713. All right, now let's go over to the second mini equation here. This one's actually quite a bit easier because I don't have to worry about any calculators. So get sine alone first by adding 1 to both sides. Where does sine equal 1? That only occurs in one spot on the unit circle, and that's going to be at pi over 2. So notice I have two different kinds of solutions here. One of them is an exact solution because it came off of our memorized unit circle. And the other two solutions are not exact solutions. They are approximations because they were not off of my memorized unit circle. So just understand that you may have one of each type of solution. All right, let's go to example number 4. Now this one gives us a hint about the fact that we're going to be using the quadratic formula. But if you didn't know that it was going to be the quadratic formula, how would you decide on that? Well, the first thing is that I would go ahead and get 0 on one side. It definitely looks like a quadratic equation, and it even kind of looks like the one that we had up here. Problem is that if you try to factor, you're not going to be able to factor this. So that's kind of our clue that the quadratic formula is a good option on this, besides the fact it was also written in the instructions. Up here I wrote the quadratic formula. We have done this in past classes. I expect you to know this. This is not something that I would give you. So just to understand, be aware, sorry about that, be aware of the quadratic formula. Okay. For the quadratic formula, notice we have to have an A, a B value, and a C value. So I just made a real quick list of that. My A value is 1, my B value is a positive 2, my C value is a negative 1. All right, so let's go ahead and plug into the quadratic formula, excuse me. And so you can pause and write that in, but I've got my negative B plus or minus the square root of B squared minus 4AC all over 2A. If I go ahead and clean that up then, this is going to be a negative 2 over 2. I personally like to take my common denominator and split it between the two terms up on top, plus or minus the square root of 8 over 2. Remember that square root of 8 is the same thing as 2 root 2, which means that I can clean that up a little bit. This gives me two separate equations, so let's put out some mini equations then. Cosine is either going to equal negative 1 plus the square root of 2, or cosine is going to equal negative 1 minus the square root of 2. Now, this is definitely going to be a calculator type of question. Make sure that your calculator is in radian mode according to the instructions. But before I hit the calculator, let's come up with a plan. I know that this number here is a positive number because root 2 is larger than a negative 1. So where is cosine positive? I know that my solutions are going to occur in the first and the fourth quadrant. This one over here, I know that this is a negative number because two negatives, when combined, give you a negative. So where is cosine negative? I'm looking for a solution in the second quadrant and in the third quadrant. All right, so let's go ahead then and solve for our first mini equation. This is something that you're going to use inverses on. So to find my angle, I'm going to use cosine inverse of this number. We'll plug that into the calculator. Again, I'm in radian mode, and I should get 1.1437. This is going to be a first quadrant angle. Just a real quick review. Remember that this is 0, this is 3.14, that's pi. This is going to be 1.57, and this one is 4.71. and 6.28. So just as a reminder of what the radian values look like when they are in decimal form. Now, that is going to give me my first quadrant answer. My fourth quadrant answer, I could call it negative 1.1437. Unfortunately, even though that's correct, it does not meet my restriction. So what I need to do then is, I'll get back to it. What I need to do, if this is a distance of 1.14, I also want a distance of 1.14 here. So 2 pi minus that distance will give me my fourth quadrant answer, which is going to be 5.1395. All right, now let's go over to the other side, and let's do the exact same thing. And so we say, hey, x is equal to cosine inverse of this ugly number right here. and all of a sudden my calculator returns an error, and when we think about it, that makes a lot of sense. We know that this number is larger than -1. It is past -1. Remember that all cosine values have to fall within the range of -1 to +1, and this falls outside of that range. So that's why we get an error in the calculator. This number is too big, so there are no angles in the second and the third quadrant that will meet the requirements. So my two solutions then are just the 1.14 and the 5.13, those two numbers. All right, so I'm going to stop the video here, and then I'll come back and continue some examples.